last MTSC session, we covered the overall operation of the automatic temperature control system, explaining just what the driver can expect under various conditions. In this session, we'll talk about the reasons why a driver might not get what he expects. In other words, how to diagnose Auto-Temp difficulties and what to do about them. Bob, you did such a good job in the last Master Technicians meeting, I decided to give you a break again this month. I'm sure you appreciate that.
Matter of fact, I do, Tech. I find that the more times I explain it, the better I understand it myself. Tell you what, Jack, why don't you start things off by giving us a short review on how the Auto-Temp unit works, just to make sure you were on the ball last month.
Nothing to it, Bob. I had the best possible instructors. One important thing to keep in mind is that the refrigeration and air distribution systems in Auto-Temp are no different than those in the conventional reheat air conditioner. Only the method of controlling is different. The temperature control is taken almost completely out of the hands of the driver and occupants by 3 small electrical regulators. One reacts to the selections of the driver, the others react to the existing conditions. 2 of the regulators, called sensors, pick up the temperature of the air inside the car and the air entering the car and change these temperatures into electrical signals. These are the existing conditions. The 3rd regulator, called a temperature selector, also generates an electrical signal. But this signal depends on the setting of a comfortable temperature. This is the desired condition. The signals from these 3 conditions are transmitted to a black box type control unit located behind the right-hand side cowl trim panel. Inside the control unit, the 3 signals are translated into work orders, which are directed to the various air distribution doors, the water valve, and the blower speed selector inside the control unit itself. The air conditioning compressor clutch is engaged whenever any of the instrument panel push buttons is pressed, except the off button if the outside temperature is above 32 degrees. The electrical circuit for the clutch is independent of the control unit, so it does not respond to any signals from the sensors or the thumb wheel.
Looks to me like Bob's explanation last month soaked in real good, Jack. And you can always review the reference book for that session to refresh yourself on the details. Right now, though, we'd better get into the diagnosis and testing procedures. What's the story, Bob?
Well, Tech, the story is that this unit is just as easy to diagnose as any other air conditioner if you know what to look for and how to track down the possibilities. I don't think we need to go into too much detail about the obvious things that cause cooling and heating problems on the conventional air conditioner, even though many of them also apply to this unit. For example, if you're supposed to be getting air from one place and it comes from somewhere else, you know that the logical starting place to track down the problem is at the air distribution doors. It might be a matter of pinched or improperly connected vacuum actuator hoses, or it could be that some linkage is not adjusted properly. These are conditions that you should recognize from your understanding of the conventional air conditioning system. The refrigeration section of Auto-Temp is almost identical with the conventional unit also. The only real difference is the substitution of the evaporator temperature regulator valve for the evaporator pressure regulator valve. But they have the same general function, so basic refrigeration diagnosis won't be changed. The control circuits, both electrical and vacuum, are entirely new and include some components that we haven't seen before. So our diagnosis discussion for today will concentrate on the controls.
I've seen you using the Auto-Temp tester, Bob, but I haven't been able to figure out what it does for us.
That's a mighty valuable diagnosis tool, Jack. If you know how to use it, you'll save yourself a lot of time.
Right, Tech. Using the tester, you can check out the entire control system as well as the individual sensors and the temperature selector. To hook up the tester, remove the right-hand kick panel and disconnect the 8-terminal electrical connector. The tester has a male and a female 8-terminal connector to match the 2 halves of the servo unit connector. The tester has 2 other electrical connections. The black lead goes to the blower motor resistor block. Hook the clip to the terminal under the tan wire in the 3-terminal connector. The white lead goes to a solid ground. To make the vacuum connection to the tester, disconnect the control vacuum hose from the water valve thermostat and use the T and short hose to tap into the line. The first test to make is to determine whether the transducer is supplying the correct control vacuum to the water valve thermostat and the power servo. If control vacuum is not accurate, none of the other components can function properly. Set the instrument panel temperature selector at 75 and the tester voltmeter on off. Start the engine and set the idle speed at 1000 RPM. Press the auto button and slowly turn the tester vacuum control dial from minimum vacuum to calibrate. When the dial is at the calibrate position, the vacuum gauge should read between 4 and 6 inches. This reading tells you whether the amplifier and transducer are reducing manifold vacuum to the correct control vacuum value. If you don't get this reading, the whole control assembly must be replaced.
Don't be in too big a hurry to replace that control unit, Bob. Always check the manifold vacuum source as well as the hose connections before you condemn the control unit. It figures that if you're not getting full manifold vacuum to the unit, then the control vacuum is going to be affected. And here's another tip. Always tap the tester gauge with your finger until it stabilizes. Otherwise, friction in the gauge might cause an incorrect reading. And make sure all the connections are tight. What's the next test, Bob?
The next step is to check out the sensors, Tech. Turn the voltmeter dial to the ambient sensor position and the in-car sensor position. In both positions, the needle should rest between the two red areas. If it doesn't, the sensor needs to be replaced. With the voltmeter dial on the temperature control position, the needle should also be between the two red areas. If it isn't, the potentiometer should be replaced or calibrated.
It's a simple matter to check the calibration. You'll find a good description of the procedure in your service manual. Incidentally, if the needle is in the red area to the left, the unit is shorted. A needle in the red area to the right indicates an open.
I don't understand how the tester checks out the sensors and the selector.
Well, very quickly, Jack, when the tester is used to check the control unit calibration, the sensors and the selector are bypassed inside the tester. The bypass circuits substitute resistance for the units that is equivalent to 75 degrees at the two sensors and an equal setting on the selector. In testing the sensors, the tester sends a current through the selected sensor or the temperature selector. The voltmeter shows the amount of voltage drop across the units, which is one method of testing for resistance. Incidentally, Jack, when you're testing the sensors and selector, don't leave the dial in any of the 3 test positions for more than 30 seconds. If you do, you're liable to ruin a good sensor or selector. You can also use the tester as a test probe to see if a circuit is live. First, unplug the 8-terminal connector. Then ground the white lead solidly and use the black lead to test for voltage at the various switches under the various operating conditions. The operating conditions are as many and as varied as there are combinations of signals from the 2 sensors and the instrument panel selector. It's almost impossible to predict every condition of temperature, so let's look at some basic possibilities. To prepare for the push-button test, place a thermometer in the right center air conditioning outlet. Set the vacuum control dial at minimum vacuum and the voltmeter dial on voltage. With the engine running at 1000 RPM and the off button pushed, the tester voltmeter and the vacuum gauge will read 0. This is the starting point to check out the operation of the entire system. With these conditions, and knowing that the sensors and the control vacuum output are correct, we're ready to go through the push-button positions to pinpoint any problems. That is, as soon as Tech takes care of that old subject.
I don't even get a chance to interrupt anymore. Someone better turn the record.
As a first test of the complete system, push in the auto button. There shouldn't be any change in the vacuum gauge reading, but the fresh air door should be at the 20% open position and the blower should be at the high air conditioning speed. You should be getting cool air from the air conditioning outlets and the air temperature should drop. That's because the tester vacuum dial, which is acting as a selector dial, is asking for less heat because of the low vacuum. To further check the auto push-button operation, slowly move the tester vacuum control dial from minimum vacuum toward maximum vacuum. The system will go through a number of changes during the process, starting with a drop in blower speed to M3 at about 2.5 inches. When the vacuum gauge reading increases to about 3.5 inches, the fresh air door will open all the way to 100% fresh air. As the vacuum control dial is turned further toward maximum vacuum, the blower will continue to slow down and the output air temperature will begin to rise. This will continue until the gauge reaches about 8 inches of vacuum.
As the blower speed changes, you'll be able to see the voltmeter needle move. When the control vacuum reaches about 8 inches, the system makes the transition from upper air conditioning outlets to lower heater outlets.
I remember that, Tech. In fact, that's the easiest way for me to remember the operation. High vacuum means high heat, and low vacuum means less heat.
Right, Jack. And at the transition point, the output air temperature should be at about 85 degrees, give or take 10 degrees. Then, as soon as the change is made, the blower starts to speed up, and the temperature continues to increase. As you continue moving the dial toward maximum vacuum, the blower will make 2 more increases in speed, and the output temperature will continue to rise. At 12 inches vacuum, the blower will be on M3, and the temperature will be about 140 degrees. Turn the dial back to get 8 inches on the vacuum gauge. At this point, with the auto button pushed, the blower will be on low. Push the high auto button and see if the blower goes from low to M3 speed. Why should this happen, Jack?
If I remember correctly, pushing the high auto button bypasses the control unit and goes through only one of the resistors in the blower resistor block. So, in the high auto position, the low speeds are eliminated.
That's right, Jack. Now, to check out the defroster buttons, you have to again return to the auto button position. So push the auto button and set the tester vacuum dial so the gauge reads 8 inches. Pushing the defrost button doesn't change the vacuum reading, but the air conditioning outlets will be closed off. All of the air will be coming out of the defroster outlets except for the normal 20% bleed through the heater doors. The output air temperature will be the same as in the auto position, but the blower speed will be in M2. That's because the current from the push button goes through only 2 resistors in the resistor block. The last push button test is on high defrost. With this button pushed, you'll get full control vacuum, which will call for the highest heat, and the blower will run at the highest heat speed.
That's because the high defrost push button bypasses the sensors and the instrument panel selector. In fact, on high defrost, you can move the selector through the full range without any effect on the blower speed or the temperature. Now, Bob, there are some other components that can give some symptoms that might be mistaken for sensor or control unit problems. How about telling us about them?
Sure thing, Tech, but there's one thing that should tell you if it's another unit. If the blower goes through all the speeds during the test we've just covered, you can be pretty sure that the control unit is operating correctly. The first thing I always look for is a pinched vacuum hose or a bad hose connection. In fact, I usually check them all out before I go through the sensor test. I've cut down a lot of lost time that way and avoided unnecessary control unit replacement. Another test comes early in my procedure, especially when the output air is too warm. When this happens, I have to take a look at the water valve operation. The water valve is operated by vacuum against a calibrated spring load. In other words, the valve is closed by a spring and opened by the modulated vacuum from the water valve thermostat. To make this test, make sure the engine is warmed up normally. Remove the red tracer vacuum hose from the water valve thermostat and connect the hose to an external vacuum source with an inline gauge. Put a thermometer in the right center AC outlet and run the engine at 1200.
If you expect to get any air out of that outlet, you'd better set the control vacuum on your tester to get the Auto-Temp in the air conditioning mode. That means about 7 inches control vacuum.
Thanks, Tech. Set the external vacuum source to apply 3.5 inches to the water valve. At this setting, there should be no increase in the output air temperature. Start a slow increase in the vacuum supply to the water valve. At 4.5 inches, the temperature of the output air should increase 10 degrees or slightly less. Of course, you'll have to wait a short while for the thermometer to catch up. Check full opening of the water valve by turning the external vacuum supply up to 12 inches or more. This should increase the air temperature to about 140 degrees. If the valve doesn't make the grade, replace it. Now, assuming that we find the water valve doing what it's supposed to do when the correct vacuum is supplied to it, let's find out whether that vacuum is actually being supplied. To find that out, let's look at the water valve thermostat. You know that control vacuum and a bimetal spring are used to reduce manifold vacuum to a lower value, which determines how far the water valve will be open. To test the water valve thermostat, pull the vacuum hose with a red tracer off the thermostat and connect a vacuum gauge to that thermostat connector. That hose with a red tracer is the one that goes to the water valve. Disconnect the wires from the compressor clutch and run the engine at curb idle speed. Place a thermometer in the right center air conditioning outlet, push the auto button, and set the tester vacuum dial so the tester vacuum gauge reads 7 inches. This is the control vacuum supply to the water valve thermostat. When the thermometer in the outlet settles down, it should read the same as the ambient temperature outside the car. Remember, the compressor is disconnected and the water valve should be closed. When the thermometer has stabilized, read the vacuum gauge that you connected to the thermostat connector. The vacuum will vary according to the temperature of the outlet air. There's a table of calibration in your service manual to tell you whether the thermostat is okay.
Wait a minute. If there's no heating and no cooling, and the control vacuum is constant, why should the modulated water valve vacuum vary?
I'm glad to see you're on the ball, Jack. It's because of the bimetal spring in the thermostat. If the ambient temperature is high, then the warm air passing over the thermostat is going to activate the spring and bring it against the modulating stem in the thermostat. And this will reduce the value of the modulated vacuum.
Another component that you won't find on conventional air conditioners is a vacuum transfer switch. This switch combines with a spring and a vacuum actuator to control the position of the fresh air door. With the engine running and the off button pushed, the fresh air door should be closed. You can check this by reaching through the grill and pushing on the door. Disconnect the solid black vacuum line at the water valve thermostat. This is the control vacuum line. Set the temperature selector at the lowest point and press the auto button. The door should move to the 20% open position. Reconnect the vacuum line at the thermostat and move the selector to the highest heat position. This should move the fresh air door to the fully opened position. If any of these positions is incorrect, replace the transfer switch.
Bob, I know you have more ground that you want to cover on the Auto-Temp system. However, we don't have much more ground on the record. So let me wind things up for today. The Auto-Temp unit looks real hairy the first time around. And let's face it, there are a few new things to learn. But that's true with any new unit. That's why I want all you master technicians to pay special attention to the reference book for this session. Don't just look through it and lay it aside. Look through it again, and then once more. There's a good possibility that we'll have another go at Auto-Temp in a future session. So put this reference book with the one on the previous session and keep them close at hand. Look them both over from time to time and keep cool.